Alright, the first part of lesson 21 deals with the product rule for exponents. First, when we look at a number with an exponent, if we had 5 to the third, we write it up here, and 5 to the third, the 5 is considered the base, and then the 3 is considered the exponent. So here's a base of 5 and we're squaring it, and then we're multiplying that times the base of 5 to the third power. So we need to know those terms. But when we look at what this means, we know that 5 squared means 5 times 5. And then we're going to take that and we're going to multiply it times 5 to the third, which is 5 times 5 times 5. So since our only operation is multiplication in all of this, we can simplify this to be 5 to the fifth power. So if we had 2 to the third times 2 to the fourth, we have a base of 2 to the third power times the base of 2 to the fourth power. In fact, we could do this times 2 squared. Do another 2 to the second power. So what this really means is 2 times 2 times 2 times 2 to the fourth would be 2 times 2 times 2 times 2 times 2 squared would be 2 times 2. Since it's all multiplication, we would end up with 2 to the ninth power. That brings us to the product rule for exponents. The product rule for exponents states that if your bases are the same, you can add the exponents. So x to the m times x to the n, we have a base of x and a base of x. Bases are the same, so we can just simply add the exponents. So if we would have went back to our original problems here, all we needed to do is say, well, the bases are the same. We have 5 and 5, so we add the exponents 2 and 3. This is 5 to the fifth power, and that's what we came up with. Here, we could, since the bases are the same, 2, 2, and 2, we can just add the exponents. This equals 2 to the 3 plus 4 plus 2, or 2 to the ninth. So product rule for exponents says when bases are the same, you can add the exponents. So if we took a problem or two from the book, hold on one second, I'm going to pause this and clear it. Alright, there we go. Here's a couple of problems from your book. So now take out the numbers. We worked before with like 5 to the third times 5 squared. We said that equals 5 to the fifth. So now let's take away the numbers and let's deal with variables or unknowns. Here we've got x squared times x to the fifth. I suppose we could rewrite this and put our x's by each other, since those are going to be the terms with the same base. So we can add 2 plus 5 for a total of x to the seventh, and y squared times y to the third gives us y to the fifth. Since the bases are the same, we can add the exponents. So this here simplifies, these will be our directions, to this. Let's do another one. We've got m. When there's no exponent written, it really is an exponent of 1 and m. So m to the third times m to the first, this is all multiplication, times m squared for a total of m to the sixth. And then we've got p and p. So p to the first, since there's nothing written there, times p to the fifth. We can add the exponents when bases are the same. So p to the sixth. And then x to the third for a total of x to the fourth. So this is a simplification of this.